Yeah, it's a real pleasure to be here. Anand, just meeting you, months ago and having the opportunity to come talk to the faculty and the students, you guys should be honored. I mean, I've never seen an organization so concerned and caring about the school and the students. Trying to do what they can to bring in the best students around the world and trying to bring companies to hire you so that companies will be attracted to your school. And hats off to everything you're doing, and it's very impressive. And that's part of the reason I'm here, is because I want to be part of that and support you. And so thank you for having me. I'm not going to talk the whole time. I do want to leave some time for, I think the best part is when you guys ask questions. And so we'll certainly leave some time for questions and when I get done here. I do want to just say a couple things before we get into. I have some videos to show that hopefully they'll be of interest. ATK, I mean, what we do is, just to put some background, is we build a lot of things. We're the world's largest producer of rocket motors. Small stuff, like air-to-air stuff, ground-to-air stuff, medium rocket motors that, like the Minuteman, you ever heard of Minuteman, or D5, it's a submarine launch thing, or the space shuttle boosters, they're like 1 million pounds apiece. They put out 3 million pounds of thrust, big boosters. We also build some advanced missile capabilities, missile warning stuff, countermeasures, so when people get shot at, we can shoot back and defend ourselves. We're the world's largest producer of ammunition, both small, medium and large. Large meaning like tank rounds, big stuff. We do a lot of composites. We built the wings for the Joint Strike Fighter. We do composite parts for the Airbus airplane, commercial airplane. And so just a lot of those composite parts. A lot of satellite stuff. I think we build the best solar arrays in the world for space vehicles and satellites. We're actually building a satellite to go service other satellites. Launching a satellite costs a lot of money, and they're kind of far away. And so when they have a problem, you kind of call up the insurance company and say, is this covered? And most of the time they'll cover the launch, and after that, and so it's an expensive proposition. I mean, it just launches cost $50 million just to launch one, much less what satellite costs. So we're actually building a satellite that can go, piggyback itself to a satellite that's in trouble and just give it new life and just give it an extra 10 years of life. And so there's some cool things going on in the satellite world. We also do a lot of space stuff. I'll show you a video on some Mars activity. We build a lot of the tools the astronaut uses for the Hubble repair mission, and a lot of cool stuff. And so I'll share some of that with you as we get into it. We're in 22 states in the country, 16,000 employees, a good mix of engineers, business people, technicians, and I've had the opportunity to work in a number of those things. I was joking when I came here to some of the guys. I'm going to go talk to the students about how great it is to be in the aerospace and defense industry, while we're watching what's going on with sequestration. And but one thing I've learned in this business, as you'll learn, is that this is nothing new. I mean, this happens all the time. I remember years ago when they were voting on the space station. You got 30,000 people around the country working on this program, and they're going to vote on it. Well, what if they vote no? Then what happens? So it just, the defense goes up and down. So it's uncertain, but the good part is that the need for us, for engineers, for people with good business savvy, good leaders, we always have those needs. 24/7 we have those needs. Even when we're laying people off, we always have needs for talent, people that have different capabilities in different areas. And so, I'm certainly admire to what you're doing here. Just quickly on myself, I graduated in 1981. That was a few years ago. Had a mechanical engineering degree. And just a funny story. So there I was a senior. It was April 12th, 1981. Me and a couple of my college buddies were sitting on in one of the dorm room beds watching a little 9-inch black and white TV. April 12th, 1981, we watched the first space shuttle launch. Watched John Young, Bob Crippen. John Young he flew the Apollo rocket, went to the moon twice. And Crippen was an Apollo astronaut, never flew, so he waited till the shuttle. So watch these guys walk out, get on this vehicle, this space shuttle, this first winged spacecraft. And up till now, if you follow the space program, every rocket that has been flown had test vehicles, so it wasn't a first-time occurrence, had a capsule, launch escape thing on the top. So these guys walk out, this thing's never been flown before, no way to get off, there's no escape pod, no escape tower. They had these windows overhead that they could knock out and crawl out and had parachutes, but that doesn't work in a space vehicle. But so there's really no way out, and you just admire this thing, and this thing launches. And so I didn't really know what I had a couple of job offers, but I didn't really know what I was going to do with my career. So I'm a senior, a month and a half to go to graduate. Saw this thing, I said, that's what I want to do with my career. And so I went down to the part of the campus that had where the recruiters were, filled out an application to Rockwell. I looked up, who builds this thing? So Rockwell International, filled out my application, sent it in, and never heard back from them. So I graduated. I did some other interviews. I got a job with another company. Actually, U.S. Steel offered me a job to work in Pittsburgh. I grew up in New York, not too far. Folks weren't too worried about that. A couple-hour drive. So I took the job. They actually offered me a pretty interesting job out of college to be in management. I didn't really learn anything when I was an engineering student about how to lead anybody. But they offered me some leadership jobs, so I thought that was cool. So I accepted it. Went out there, did the P-test. Signed all the paperwork. Was looking for a place to live. And a week before I was supposed to start, in August, I get this phone call from Rockwell. Hey, we got your resume. You still interested in working for us? So this is a Monday. I was supposed to start the following Monday. So I said, So I said, can I come out for an interview? So 2 days later, I was in sunny Southern California, interviewing for a job, working on a space shuttle program. And so I came back home. My parents were like, what are you going to do? You already had this job. Everything's already ready to go. So I'm thinking, let's see. 20 years old, Southern California, beach, space shuttle program, Pittsburgh. Nothing wrong with Pittsburgh, So anyway, long story short, I ended up in California. But which is interesting is, when you chart your career, you never know what's going to happen. And, in fact, when I started school, I wasn't even an engineer. I was a pre-med student, and I changed when I was a junior of all things, which is a whole other story. But so what we watched the launch, it gave me a path. So I started on the space program, and so I worked at Rockwell for a couple of years, and then when I was there, I was working in engineering. It wasn't enough. I was like, is this it? Worked in a department, had my cubicle. They gave me stuff, and it wasn't enough. And I've since learned, as you'll see, you have all this energy, all these ideas when you come out of college, and and they give you something to do, and it's not enough. And so I was looking for more. So fortunately, I didn't leave the company. Fortunately, I had known enough people that somebody said, hey, you ought to go work in quality. And I said, what's quality? Quality is, and I didn't, again, being an engineering student, they didn't teach about other engineering disciplines, reliability engineering, quality engineering, software engineering, or software quality engineering, manufacturing engineering. And so anyway, so I said, sure. So I went, checked out the job. It was pretty interesting. It was troubleshooting space hardware that came back and how to make it better. So I took the job, and I just loved it. I mean, I just and I never would have expected when I was in school I was going to end up in a quality engineering job, because I didn't even know they existed. So I took the job, and I just, to me, it just connected more dots for me. I learned more parts about the organization. I realized how bad an engineer I was, because when you're in engineering, you're designing stuff. You're not talking to the people that could build it. You're not talking to the people that can inspect it. You're not talking to production control that figures out what the inventory levels are. You're just designing stuff and just sticking it in the system. And now when you're on the other side, it's like, what is this garbage? So I learned about configuration control. I learned about tolerancing. You're an engineer. You think you know about tolerancing, but you learn producibility and inspectability. That's what tolerancing is all about. If you can't build it, you can't inspect it, tolerances don't mean anything. And so you learn about that stuff. And then, so I rotated around. I worked for a boss that was a great boss. And he was a great boss because he gave all his assignments to his employees. And so we got stuff, we were doing stuff that only management did, because he just trusted us. And he sent me to work at a test facility for 6 months. He sent me to the Kennedy Space Center for 6 months. I worked in just a bunch of departments, and so I was just learning stuff, and I was having a great time. And then Challenger happened, right? Who would have predicted that? And bad day for the space world. So I was at Rockwell, and so Challenger happened, which is a booster problem, a company called Thiokol in Utah. So a year or so later, I got a phone call. It says, hey, the NASA guys think that you'd be great working out here, helping us rebuild this place and helping us get back on a path. And you know, you want to come work for us. And I'm like, I don't think I want to leave Rockwell. You know, I got a great job. I was, you know, I had been promoted. I was pretty young, doing well. Liked, you know, I had a lot of friends. And then I was telling the story to somebody else. Then my boss quits. And I say, well, you know, it's like, what's up with that, you know? So my boss quits. He gets this big job building C-17 aircraft for McDonnell Douglas. And so I'm thinking, well, if he can leave, you know. So I never actually ever thought about, you know, you build some loyalty to a company. So, you know, anyway, I ended up taking the job in Utah. And, you know, it was great. I mean, we ended up rebuilding the place. We won a bunch of NASA awards. We were making money. We were buying other companies. We were doing acquisitions. We were doing, I mean, things were just going really well. You know, I moved into manufacturing, was building hardware, moved into other departments. And then we got bought by Alcoa. So what's an aluminum company buying a rocket company? So they bought us, had us for a year, and then they realized, you know, we don't know what to do with these guys. So they sold us to ATK. So 2001, you know, I became an ATK employee, having come up through all this propulsion stuff, and ran the space business till we decided to retire the space shuttle, and then we had a whole new set of launch vehicles, and then the Obama administration decided, you know, I don't want to do that. I want to do something else, and so the space business kind of is changing, is in a transition mode because we're doing something else. So the CEO said, hey, you want to come to Baltimore and run on defense stuff? And I really hadn't spent much time. I understood all technology, but I didn't have much time doing defense stuff. So I said, sure. So I've been out here for 3 years doing the defense stuff. So the moral of the story is, if you would have asked me in 1982 where my career was going to go, I would have had no idea. You know, there's no way I would have said what I just told you. But and you know, my guess is many of you will have the same thing. You know, the same careers. You know, you got opportunities. Some of you say yes, some of you say no. Some will fit what you like to do. And so what I want to do is later on tell you what some of the keys to what I thought was successful. You know, what was important in my career that made me do well. And you know, of course, I ate my vegetables and I listened to my mother. You know, I did all those things. But beyond that, there were some things that I do want to share with you. So I have a couple of video clips. The first one is just of some folks at the company. So you can show the first video clip.
Exciting part about working here is knowing that you contribute to major space programs and that your products are used to save lives.
I think all of us here have a sense that you know, we're doing something meaningful here. You know, every individual that's here assembling our hardware, there's a dedication to doing the job and doing the job right because we know it's important. We know our customers depend on us.
The type of deployables that we offer here are unique. There really is no one else in the world who does them. This is an example of a deployable boom that's lighter weight and higher performance in terms of its structural efficiency than any other technology that's been put in space before.
The fundamental mindset of our customer is they are visionary. They, as an entity, an organization, are able to do things no one else can, so they're very passionate about it. They're looking for high quality, high reliability, lower risk, and lower cost all the way along. And if we can continue to integrate new technologies into our products that bring the better quality, the better reliability, and the lower cost, we make them very, very pleased, and that's what we strive to do.
Everyone's my customer. My customer is an operator on the floor. My boss is my customer.
our customers are very demanding, and we use new technology and the latest technology many times to give them the reliability they need.
I was listening to NPR just yesterday, and they talked about the Messenger satellite that's going to be swinging by Mercury here, and we launched that. National Geographic, they had some pictures of Jupiter that came from a satellite that we launched, the Cassini satellite.
The real customer is our soldier in the field. That's how we look at it. Because every gun has to go out. When they pull a trigger, we want action. And they get firepower. So that's really my main motivation.
I have a son who is in Marine boot camp. If we don't make a quality product, we don't make sure that that goes off every time, it's their life on the line.
It's cool stuff. I don't know anybody else that does stuff as cool as what we get to do.
Well, if you've ever been down to the Cape and watched the space shuttle go off, that's very exciting. Knowing that you had a small part to play in that, in the Mixed Cast Work Center, we mix the propellant, put in the rocket motor, and knowing everything that goes into that to make that motor operate is very exciting.
So I showed you that clip for a couple of reasons, but the main thing is part of the theme of what I want to talk about. It's not about it's not about the work. It's not about the tools. It's not about the new gadgets. It's about the customer. It's about the people. Every one of these folks that was on that video, they work. They work in a variety of places, but as you can tell, I mean, they're just passionate about what they do, and they can connect with why they're doing it. And and my job as a leader is to facilitate that. And it's more important for me to connect people to what they do. I mean, we had suppliers that were doing stuff they didn't even know where the parts went. You go into their factories, and they don't know if it was going in a F-150 or going in a space shuttle. I mean, so when you show it to them, it's like, wow, really? And all of a sudden they get connected. And so you'll find as you get into your career, how do you connect with what you're doing? It's hard to get excited about a piece of paper, a piece of planning, a finance spreadsheet, but you can get excited about it because people make decisions on that kind of stuff for some end state cause. So I want to show you that because every time I watch, you can just kind of see the passion kind of come out of the folks that are talking on there. So another video I want to show. This one's kind of interesting. This is, unfortunately, there's no sound to this, so I'm going to narrate a little bit of it. But this one, so we had a mission we did years ago. Remember Spirit and Opportunity? Remember those, the Mars rovers? So, so NASA was about putting these things on Mars, and we don't have a lot of experience on Mars, and so we had to go do this. And so when you watch this video, and I'll talk a little about it as it's going, every step of the way is like a major thing. You're launching a rocket. You're launching a satellite out of a rocket. The satellite's got to go to Mars. It takes 7 months. It's got to land somehow. It's going super fast. Well, how's it going to land? It doesn't have an atmosphere like Earth where you can slow down, just by using the atmosphere. So, how does it do that? And then it's got and when it lands, so just all these things, and it's just amazing how you can pull this kind of stuff off. And when you find in any major goal like that, you just break it down into little pieces. You put these project teams on it. You get it focused. You get the pieces talking to each other, and before you know it, you have a couple of rovers sitting on another planet. So let's just show this video, and then I have a couple of things I want to talk about. This is a Delta rocket, and there's some boosters on the bottom that we build in Utah, right there. Actually, this would have been cool to have some sound, but see, it launches out of Florida, and so there's 9 strap-ons, and so you'll see them come off. Oh, maybe not. Oh. There they go. Then you get stage separation, then you get the second stage, takes it up, takes it probably to 300 miles, and then it ejects a vehicle that has its own power on it, and so you've got to spin stabilize on it, and you fire it again, and it gets its Mach 25 coasting speed, and then it coasts to Mars at 17,500 miles an hour. Still takes a long time. But that's got to slow down. I mean, you know, so it's got some atmosphere, but it doesn't slow it down. It's too thin, so you have to use some rocket motors to slow it down. Some parachutes. So those are airbags, the ones you have in your car, same technology. The airbags inflate it, yeah, and then rocket motor slows it down, bounces a while, and then the airbags deflate. Actually, the sequence to deflate the bags is pretty clever. They deflate such that the rovers end up on their wheels. You know, they said if you could tell how it landed, it deflates it in sequence. So that mission, I mean, that, you know, there were the people working on that, everyone working on that thing. I mean, when I was a kid, this gal I went to elementary school, her father designed the ladder for the lunar module that Neil Armstrong climbed down when he went to the moon. I thought that was the coolest thing in the world. He designed the ladder, you know, and I always remember, you know, oh, Joanne Lipton, that, you know, her dad designed the ladder on the, you know, on the LEM for the people who landed on the moon. And you know, you always wonder, how do people get those jobs? You know, how do they do that? Well, so here, you know, here you got this thing that, you know, you get a rocket, and launching a rocket's hard enough. Then you got this satellite inside, and I mean, every step of the way is just, you know, it's mind-boggling. And you have people that pull this thing off. And what's amazing is when you work in these teams, the hard part isn't the engineering. I mean, that's hard enough. The hard part is just integrating all this stuff, getting people to talk to each other. Just, you know, it's amazing. Most of the mistakes are not technical mistakes. You know, they're just oversights from communication. You know, they're just, you know, schedule disconnects between, there's a lot of pressure to get stuff done, and people are making decisions. And do you ask enough questions in reviews? And if you ask too many questions, is it going to slow it down? And the dynamics of these kind of projects, as you learn, are way more stressful than the math, or way more stressful than the budgeting or the financing. And so I just want to share that with you. But when you break it down and you get the right people and you get the right teams, you know, you can accomplish stuff like that. And we continue to. I think one of those is still actually working. And you know, they were only designed to work for a few months, and I think one worked for a full year. One's still working. So it's amazing, and it cleared the way for the recent rover that we did. And one of these days we're going to go there. And we were designing, till recently, we were designing a rocket that actually, getting to Mars still takes a long time, but you need to take a lot of fuel because you got to come back. And so you got to take all your fuel with you. And so we said, you know, maybe we can make fuel on Mars. You know, so that's why they're doing all this sampling with the new rover, what's there. Because if we can make fuel there, then what we would do is we would send over a ship. We'd send over a ship empty, and we'd fuel it, and we wouldn't launch the other one until we knew that the return vessel is fueled. And because if you had to launch a rocket and bring all your fuel that you need, it's a huge rocket, which we could build because we like building big rockets. But it'd be better if we could only have, refuel when we get there. So I wrote down a couple points I want to share with you. That the business world that we live in is really complex, and it's complex because you got probably two things. You got a lot of people, and people all think differently. They all have different opinions. They're unpredictable, and you have a lot of different departments in organizations. You have procurement, you have finance, you have production control, you have scheduling, receiving, shipping, engineering, all the different engineering disciplines, and they're not. And the organizational structure is such that they usually are not integrated in an ideal fashion. So they all work for different people, and they have different budgets, and they have different metrics and different goals. And so the organization becomes complicated. So how do you excel in an organization that's complicated like that? You're not going to solve it. And even when you get to the top, you're not going to solve it because you're going to be preoccupied with making charts for the board of directors. And our job is to make tomorrow better than today and make the system better, simplify things. And so I just wrote down a couple things that are important when you get into these organizations. Stay focused on your objective. You know, just stay focused. There's so many ways to get off on a tangent. I mean, it's just so easy because things are so complicated. It's so easy to get hung up on, I call it sub-optimized, hung up on some solution that's really not, you know, not the ultimate objective. I mean, you're a manufacturing engineer. You write planning for the guys on the line, and you know, you're busy, you're swamped, you got so much to do. And so do you go out of your way to give them all the details, or do you reference stuff? Well, you know, do this and torque it per the torque spec, and after you weld it, you know, inspect it per the weld spec. And so do you reference stuff? Well, just think about it. So if you're a manufacturing engineer and you reference stuff, you know, and you do that, you probably get your job done a lot faster. It's accurate, it's technically accurate, but you're going to hand it off to somebody else. So now I'm the operator on the floor. I get this piece of planning, and it says torque it to the torque spec. Well, who's got the torque spec? You know, I mean, I got to go find it. You know, and I'm not going to go find it. You know, there's no specs on the floor. I got to go find this thing. I'm going to go ask my buddy, hey, what's, you know, is this 25 foot-pounds? I just did this last week. What, you know, you're creating a bad situation. You know, or the welding spec. You know, there's so that manufacturing engineer, he sub-optimized his job to make, he did his job. He was technically correct, but he didn't help the ultimate objective, which is let's get this stuff built in the best, easiest, simplest way possible that gives us the highest probability of success. He didn't do that. He just kind of passed the buck, if you will. And so there's a lot of that going on. And so the only advice is, you know, remind yourself always of the objective, and whatever you can do to help the ultimate objective, try not to sub-optimize. Ask questions. Speak up. And keep asking them until you understand. I mean, I go to meetings, and you know, sometimes, am I the only idiot in the room that doesn't understand this? You know, really? You know, so people don't ask questions. I don't get it. You know, they just, I mean, everyone's busy. You know, got an hour meeting. You know, there's 5 minutes left. You know, sometimes the time that's more important than asking questions. And sometimes people ask questions, but then they stop. You know, they ask a question, they get an answer. Oh, okay, that makes sense. But you know, but that doesn't. You don't really. So we got asking. You know, we learned that, unfortunately. You know, Challenger, Columbia. You know, we had those issues. We were asked questions, we got answers, we were happy, and we went on. And we were asking questions. Our subconscious was asking questions such that we would get a good answer that fit what we wanted it to be, and then we moved on. So, again, when you're in organizations, if it doesn't sound right, just speak up, ask questions. No one's going to criticize you, and just keep asking until you understand it, because more than likely, people in the room will appreciate that, because they'll probably figure it out at the same time you did. Oh, there's more to the story. Oh, I didn't know that. Oh. And there's always more to the story. Let me tell you that. There's always more to the story. Value other people's point of view. Value other people's point of view. You're going to work in an organization where no one, you know, not everybody's going to always agree with you. In fact, you can count on, you know, there's always people out there that don't agree with. I mean, there's just always disagreement, and it's a kind of a hassle dealing with people that don't agree with you, because now your job is harder. But you need to value that, because you may learn something. No, let me take that back. You will learn something if you value other people's opinion. And you know, it's not that dissension is important, but you know, other people have point of views, and if you ask questions to try to understand why they think that way, you'll probably learn something. And that's just an important point. A couple more. This one's interesting. Don't be afraid to ask for data. Don't be afraid to ask for data. And this is kind of a human nature thing. And outside the launch control room in Florida, there's an office, and it says, "In God we trust, all others bring data." You probably heard that before. But that is, I mean, people, you'll bump into people that have really strong opinions. And if they happen to have 30 years of experience in there, then okay, fine, they're probably right. But maybe they don't. Maybe they just have a strong opinion. And so if it doesn't sound right, there's nothing wrong with asking for data. Because if you have the data, then it's black and white. And you know, people think it's offensive. You know, someone comes up with it and you say, "Well, do you have any data?" So I mean, you're not really offending anybody. You know, you just are asking for the data, because you'd be surprised. There's more times than not the data doesn't substantiate the claim or the opinion. So it's good to ask for the data, and to go along with that, which is really important. It's relationships. When you're in an organization, the relationships you build with other people are really important because it makes it easier to ask those questions. It's hard to ask a question to somebody you don't know. And so as you go work in organizations and you learn who your internal and external customers are, building relationships, which is, doesn't mean you have to join a bowling team with that person, but just getting to know what they do, having an excuse to sit down with them, go through documents, so that there's a relationship there. So if there's a question they have or you have, someone's picking up the phone and asking legitimate questions that are important. And if you can't do that, then the work you do is somewhat at risk because you're relying on information from other people and you don't really know what it's founded on. So and then always do good work, even when people aren't looking, because people are always looking. And so one thing that I learned, and this, I mentioned we got bought by Alcoa. So here we are, Rocket Motor Company, smartest engineers in the world. Alcoa buys us. What are we going to learn from them, right? And so they had this thing called ABS, the Alcoa Business System, and they required every manager in the organization to go through this ABS training. It was a week long. It's like, oh my God, just because they bought us now we got to go through all this training. So anyway, I was, I signed up for my training, and it was phenomenal. It was phenomenal, and I'd been going through TQM school, and I've been going through all these initiatives throughout my career, and so here's what they taught you. I mean, I'll narrow it down in a week to 3 minutes, but what they basically did was they were losing a lot of money. I forget what year it was. So they decided they were going to follow what the companies that implemented the Toyota production system were doing. They felt the Toyota production system was the best production system in the world. The philosophy was based on, was the right philosophy, and the companies that implemented that were basically successful. So they decided they were going to learn from the Toyota production system experts, and so they spent years, millions of dollars. They were doing all this stuff, and they didn't save a dime, right? They weren't saving a nickel. They were doing all the Kaizen reviews, had SPC charts, you had, fishbone diagrams, and you guys can probably rattle off all the rest of that stuff they were doing. And they weren't saving a nickel. So they hired a bunch of guys out of another business school. They didn't know about you guys here. So they had the Quest program. They would have called you guys in, but they hired they hired a couple of guys, and they said, "Tell us what we're doing wrong. What are we doing wrong?" I mean, so these guys went and studied them for a few months, went and studied all these other companies, and they came back and they said, "It's not about the tools. It's about the people. You guys are missing the boat. It's about the people." So they said, 4 things. Do these 4 things, and first thing is make sure people, when they have their jobs, make it clear. Make the expectations clear. Make the job requirements clear. And so clarify what people are supposed to do, so when they do it, they feel good about it. Simple things. Second thing they said was make sure that there's relationships built between the organizations. That's what I was talking about before. People that have internal relationships, when they have questions, they'll ask the right person. And if you're an engineer and you're designing something and you have a question about how it's really built, who are you going to ask? Well, ask the guy on the floor because he builds it. He'll give you a good answer. If you ask your buddy engineer, he doesn't know any better. That's who you're going to ask if you don't have a relationship. Same with the guy on the floor. If he has a question about the engineering, you want him to call the engineer. Hey, what is this? What do you mean by this? And he said, oh, that's what I mean. So relationships, your job as a leader is to make sure that the relationships in an organization, people that need to ask questions, know each other. Third one is make things as simple as possible every day. Simplify things, because systems that are complicated, you can count on won't be done the same way every time, which means everything's unpredictable. Years ago we used to fill out these time cards. Government contracting, you got to write down your time card so you don't have a $300 hammer, that kind of stuff. And there was like a 40-page procedure how to fill out a time card. You think me or anybody else is going to read that? I'm going to, hey, Joe, how do you fill out the time card? You ask the secretary. So it's just too complicated. So people don't read the procedures. They don't follow them because they don't know what they say. They just do what they think is intuitively obvious, which means everybody does it differently. So you simplify things as much as you can so it's intuitively obvious so people can work together on standardizing that. And the last thing was improvement. Improvement should not be done by management. Improvement should be done by the people that do the work, because that's how you engage the people. And I remember in our company, you go to these corrective action boards and you go to these change boards, and it's always these managers presenting stuff because they're the experts. But that turns off all the workers because, and so engage the workforce that's doing the work in the corrective actions, because then they'll be connected to the business, because now they can go home, hey, I made a difference here. So, they basically said those 4 things. It's, make things clear, make sure, connections are there, simplify stuff, and the people that do the work should be engaged in the change process. And you do that, and sure enough, that made a difference. And the philosophy of leadership that adopted those principles, there's a lot more, there's 4.5 more days worth of stuff, but and a steak dinner at the end, but but there's a lot. So those, and I've always remembered that, clearly, and in my career, I can clearly see when leaders don't do that, the organization doesn't work. And so I just want to share that with you, because I think that was a nugget. When Alcoa sold us to ATK, we said, hey, can we keep some of this stuff? And and they said absolutely. All right, so the last clip I have, I want to share with you, is kind of cool. I'll have to narrate some of it, but this one is of, I'm not sure how many engineers we have out here or any space enthusiasts, but this goes on. This is what science really goes on inside the space station. What are they really doing there? You hear about all this cool stuff. So this is what really goes on inside the space station. And then also afterwards, after Columbia, a couple of us got together to figure out, hey, we can't fly astronauts on a winged vehicle anymore. It's just too dangerous. You don't need wings in space. There's no point to it. Plus it's dead weight. You can make that payload. And so we got together to figure out how to fly astronauts way safer than using a shuttle type system, which is kind of back to the capsule like they did in the early days, just with a lot more capability. And so the last little clips on the end, you'll see just kind of some new launch vehicles we've been working on. So let's show this. I think we start off with a shuttle launch. Yep. So you got the liquid engines firing up. They fire a couple of seconds before the boosters ignite, just to make sure they're working. And then you get the boosters igniting. 3.2 million pounds of thrust each. So you got 6.5 million pounds from the 2 boosters on the side, and then the 3 engines off the back of the orbiter, about 500,000 pounds each. So after 2 minutes, the boosters separate. So this camera's on the tank. Now it's on the boosters looking up. So the shuttle keeps flying. That flies for 8.5 minutes total. And then after 8.5 minutes, the liquid oxygen, liquid hydrogen in the big orange tank is depleted. And you'll see the orbiter separates from the tank. So now the orbiter is a day and a half later. It's by the space station. It's also at 17,000 miles an hour. It docks with this football field-sized craft. That's the Hubble, by the way. They're not near each other. It's not like they're next to each other. That was just. So this is some astronauts working outside. So there's a lot of work. Putting the space station together was a lot of work. Just a lot of every piece they had to bring up. So here's the science projects. If you can see that, it's doing push-ups. You dim the lights a little bit? No. Here, dim the lights for a minute. Hey, that's a power tool. Here's Doc Harwood. Those are M&Ms in a ball of water. You got to work out every day, otherwise you lose bone mass, believe it or not. So working out's important. This wasn't much of a workout. Yeah, so when they say mission control, we're busy up here. Oh, this is cool. This is lemonade and Hawaiian punch. He's mixing them together. He's trying to mix them together. Yeah, so the next 2 clips, just if you remember what the boosters looked like on the side of the shuttle, so we took one of those boosters and we built a liquid second stage, and made a rocket that has a capsule on top.
2, 1.
See it? That first stage is actually one of the shuttle boosters.
Testing concepts for the future.
And then one of those engines on the back of the orbiter is the second stage. And then you can see on top, there's a pointy thing on top. A pointy thing on top, that's an escape rocket that if you have to get off during the mission, which is the next clip, we were demonstrating how we can do an abort off the launch vehicle. So I didn't show the whole clip here. I think it's going to.
Now passing Mach 2. Vehicle now 10 miles altitude, downrange distance 8 miles, and velocity of 1580 seconds. We've started our supersonic large amplitude ID maneuver PTI. We see the response.
Kind of a cool shot of Earth.
The last PTI maneuver, structural mode ID, and we passed T+105 seconds.
So here's that's a capsule being pulled by the launch abort tower. We just did that off the ground. So there's the capsule below it, and there's a launch rocket, and it's flipping it over. And then it's going to separate the capsule. So this is in the event of emergency. How do you separate the capsule from the rocket? And then the capsule. So it's a lot of cool stuff. So after Columbia, and we started talking about how do we build a new rocket, there's no budget for this kind of stuff, and so finance guys, we were saying, hey, let's take a shuttle booster. These are $50 million a piece. Let's build a second stage for it. Let's go back to the capsule design because it's just a lot safer. And where are you going to get the money? Where's this coming? This isn't in the budget. And so so that's when you realize from a business standpoint, how do you fund these kind of projects? And so, you learn. This is when I didn't pay attention in business school about the marketing classes and those other classes. This is when you realize the word stakeholders, right? You guys use the word stakeholders in some of your classes. Who are the stakeholders? Well, in my business, there's a lot of stakeholders. In fact, in the space business, everybody's a stakeholder. But so what we have to do, we have to go find the stakeholders. And the stakeholders in our business, you got the customers. So it could be the Navy, could be the Air Force, could be NASA. Fine, but they don't control the government budget. They just manage the project, right? So then you have to go. So then there's these committees. There's these House Armed Services committees. There's all these committees out there that the government has that actually control the budgets. But the people on the committee, they actually work for some congressman or senator. So you got to make sure you're talking to the congressmen or senators so that the people, the staffers that they have there on these committees are supportive of your program. And they figure out where the money's coming from. And then you have the people that, OMB, the Office of Management Budget, the policy writers, that write space policy, the people that interface with, with Air Force, all the guys that, so everybody is a stakeholder. Any one of those could say no, and you're done. And so we have to figure out how do we package up our story and get all these stakeholders to, to agree so we can get the go-ahead. And it's just, and so you just learn. And so, I mean, when you start your career, if you ever have an opportunity to get on a business development activity, I would take it because you learn about stakeholders you never thought you had, and you learn, and it's just amazing. I mean, it's we think about the ultimate customer, but just the stakeholders, getting projects approved are just broad. Even the media, and the media could kill you. I mean, if the media doesn't like what you're doing, they could write stuff till the cows come home, and there's nothing you could do about it. And so you got to be responsive to the media because they could help you. They could write good stories. They could publish stuff in the right papers. There's no round of marketing that we could do that could overcome what the media could do to you if you don't have a good story. And you got to get the congressmen. You got to get the committees. So you get the stakeholders lined up, and before you know it, you're flying a rocket like that. So very exciting. And so I have a couple charts I want to do, and then we'll leave the time open for some questions. I have 3 charts that I thought would be appropriate for just to get your thoughts flowing. So this is a chart. It's called Operational Excellence. And I showed you this chart because in the business world, we always remember that in the center of what we do is the people that do the work. And if you're an engineer and you're delivering a drawing, then you're in the center. But if it's a product that you're doing, then it's the people that build the product. And if it's a spreadsheet for some other company, and so again, the people in the middle that deliver the product, we always have to remember that's what we're doing. And then this yellow ring, we have to make sure that there's procedures and systems in place that support them. There's policies, there's requirements, there's the material availability. Who's buying this stuff? Is it coming in just in time? Is it coming in a week early? If it comes in too early, does it have shelf life on it? So is the equipment and the tools reliable? Is there a calibration system? So we have to make sure that all the support structure that is needed to support the folks doing the work is in place. And by the way, these are all different organizations. This isn't one group doing all this stuff. They're all different organizations. And so they all have to talk to each other. And then the blue trend is, what are we doing to make sure that the system's working from a management standpoint? Starting on the left, do we have factories that are utilized? Do we have one factory that we're laying people off and we're bringing work to a different factory? So we got to keep that in mind. We're doing SPC. So another class I didn't pay a lot of attention to, statistics. You guys taking statistics? Nobody's taking statistics? Yeah, so when we build hardware, statistics is huge. Because you build these engineering limits out here, and then you build hardware, and you find out your family of data is very tight, and then all of a sudden you build some hardware, and you get a data point that's out of family within engineering, and if you didn't take statistics, like, well, what's wrong with that? It's within my engineering, it should be good. But the person who took statistics will tell you, no, wait a minute, that something changed. That should not have happened. Something must have changed in that piece of hardware. Because it's out of your 3 Sigma family, something changed, and you should go figure out what that is before you fly it or before you deliver it, because there's probably something different about it that you ought to understand. And if you didn't have a statistics, you wouldn't appreciate that. And, or similar, I was giving a presentation to our board recently on what's our business model for the next couple of years. We have 600 programs. I don't have a crystal ball, so I can't tell them exactly this one's going to grow, this one's going to shrink. When the government doesn't even know what they're doing. So I can't. So when I'm done, they say, "What's your confidence level? What's your confidence? Is it 50%, 75?" And so I'm like, And so what I could tell them is, well, we ran all these Monte Carlos, right? So when I was in business school and they were using the Monte Carlo word, I'm thinking race cars. I wasn't. But now it makes perfect sense. You use those tools because you can't really. When someone above you says, "What's your confidence level?" you can't make up an answer back to the data. I could say 50%. Well, what's that based on? Not based on anything. And so Monte Carlo, those kind of tools help you. So statistics is something that you'll find later in your career you probably should have paid more attention to, as I did. Your process FEMAs, that's just making sure we can, you always worry about things that are failing. So you should always ask yourself, how could this go wrong? What am I doing? What could go wrong in this equation? What could go wrong with my design? What could go wrong with my process? So you're putting safeguards in place. Safety is number one in any company. Obviously, you never want to have people get hurt. The minimum variety of parts. The car industries figured this thing out years ago. I used to work on cars when I was younger, and I'd go to the parts store, and they would have a part for every car, and they were always different. And later, when the car company started making money, you'll notice you went to a car company and a switch for a roll-up window was the same switch for every Ford Lincoln Mercury car, the same switch. Years ago, everyone had a different switch. And so they realized we ought to maximize using the same parts because, again, back to standards and telling your lot size so you don't have all your cash tied up in inventory, and you can read the rest of it. And then you ought to have metrics. You ought to have data that says, how are we doing? We're getting better, we're getting worse, things getting more costly. So you got to put metrics in place to give you some feel, again, so you have data versus a problem happened, then you assume everything's broken. You have some data to tell you, is the system getting better, is it getting worse, what's happening? And so I kind of show you this just to remind you that organizations are very complex because there's a lot of moving parts, and every one of those is a different organization, different thinking. You can have different priorities. People are going to agree with you, not agree with you. People are going to interpret data differently. And so the more as you start your career, the more you start understanding how things work together, the more successful you'll be because there's not a lot of people that really understand all these moving parts. And if you can figure it out, then you'll be sought after to help lead part of the organization. Next chart. I thought you liked the next chart. This was, hey, we're always hiring people. Whether new hires like yourselves or internally, there's always something going on. And so, just from my experience, what do they talk about? What do the management talk about? You know, and so all these questions are stuff that after the interviewee leaves the room, you know, they do a good job. Do they do more than their job? They always produce results. You know, you can kind of read through those things. And there's probably nothing new in that list. And so what I put on the right-hand side was, you know, what's the takeaway on this chart? What's the, you know all that stuff. You know not to answer your cell phone in an interview. You know to dress properly. You know, cover your mouth when you sneeze and all that kind of stuff. So the takeaway is think about a job. Earn the job before you get it. I mean, when people interview folks for jobs, you know, they want to get a feel for, they want to envision this person in the job, and because managers don't like taking risks. You know, I mean, risk is an interesting word. So if they see you as somebody that they already know you can do the job, you somehow demonstrated it somehow, then it's an easy decision. And so demonstrating that you're not a risk, demonstrating that, you know, what you're asking me to do, I've done that here, I've done that there. I mean, you don't want to lie, but so to the degree, and like in my career, whether you do it intentionally or not, but when you learn stuff and you start doing stuff and then you go after the job, it's easy. When you go after a job that you have no basis for, it's harder. But when you've been doing it, hey, I like doing this, I'm going to go do it, you know, then you've basically been doing the job. You know, you volunteer to be on other projects, you know, you volunteer to be on an MRP project, and then there's an opening in IT. Well, you know, you already kind of demonstrated to the management. You probably have a relationship, and so they know you, which is the third one. A mentor helps. And why do I say that? Well, so I'm in a room with 3 other managers. We just interviewed 15 people, you know, and there's trying to decide on, you know, we got the final 3, and we're trying to decide, and, you know, Mary walks in, she says, you know, I know candidate 2, let me tell you about her. And she blah, blah, blah. Oh, okay. Well, that's all we needed, just to kind of tip the scales. So a mentor helps for 2 reasons. One, they probably have some experience and they can probably give you some good advice. But when there's a job opening, if they're hiring the organization, more than likely they'll say a few positive words to the hiring manager on your behalf, and chances are, if there's not someone else doing the same thing, you'll probably get the job. And so I remember when I first became a director at Rockwell, there was no way I would have got that job if it wasn't for a mentor that I had that convinced the vice president to give me the job because I was too young. He said, "How come this guy's too young? You know, in A&D you got to be old. You know, you can't be management unless you've been around a while. You know, it doesn't matter how smart you are. I mean, I'm just kind of kidding, but there are some people that believe that, and so there's no way I would have got that job. When my qualifications I wasn't smart, didn't work hard. You know, I just was too young. But there was a guy that knew what I could do, and he convinced the manager to hire me. So so those 3 things I just thought would be good takeaways to think about. And the last chart I have, this is the other thing we look for. We need leaders, and doesn't mean you have to be in management. You know, we need leaders, and to me, you know, it's like the Army. You know, be, know, do. You know, the character, knowledge, and application. What we look for in people is their character. You know, and you can read the words. I mean, the attitude is huge in our business. I mean, positive attitude. You know, getting in there and working hard, listening to other ideas. So you have to have good character. Knowledge is important, and it's not just you know how to do the math. You know, do you know the people you work with? Do you know the customers? You know, do you know the procedures? Do you know the products? So knowledge is kind of a broad thing that makes the third one really important. And because without the knowledge, I mean, you could be a brilliant, you know, knowledgeable about your product, but if you don't know the customers, you don't know the other people in the other organizations, you don't really know how things work, you can't really accomplish much. And then the third one is obviously, certainly last but not least, the do part. You know, can you influence others? Can you package up information in a manner that gets your point across in a way that could help people make the right kind of decisions? How do you operate? How do you motivate people? You know, how do you strive for improvement? Do you listen? You know, do you adopt new ideas? Are you locked into the past? Can you anticipate? Anticipate is a huge word. I mean, the ability to anticipate means that you understand the organization, you understand things well enough that you can tell what's going to happen if we do this. If I do these 3 things, this is what's going to happen. So therefore, I shouldn't do them. Or if this is the end state, this is the end state I want, how do I achieve that end state? And you start kind of going through scenarios. So your ability to anticipate is really important. In fact, Norm Augustine, who used to run Martin Marietta, you guys may recognize him. I went to listen to him speak one time in a group like this, a long time ago, and somebody asked him in the crowd, what is the #1 attribute that you look for when you hire leaders? And he said, their ability to anticipate. And that was his answer, and he stopped. He talked about it, but that was his answer. He said, if my leaders can't anticipate, then I don't want them in my organization because I'm just going to run into a ditch, or they're going to run into a ditch. He says, I want leaders that can anticipate. And so, I certainly agree with that. So anyway, I just, again, put it on there because as you think about your careers, and I know when I did, I was so worried about the schoolwork. You'll find out when you start the work, it's way broader than the schoolwork. It's about you, it's about what you learn and how you apply yourself, how you work with others, how you motivate people. So, what am I doing on time? All right, I could probably keep talking. So let me stop.